So here to talk about SniffAir. It's an open source wireless framework. So who am I? Matthew Eidelberg. I'm a security consultant in an Optives attack and pen team. The co-author of this tool, Stephen Daracott, unfortunately he is unable to be here today due to family obligations. He's also a security consultant in Optives attack and pen team. And for the most part, we're responsible for a majority of the wireless testing that we do, as well as methodology and basically troubleshooting when the shit hits the fan. So before we talk about the tool, let's talk about wireless pen testing. Why? So I like to tell clients is having internet, Ethernet, wireless in your infrastructure is great, but it's also like running Ethernet to your parking lot. You don't know who's there, you don't know who's seeing this stuff, and you don't know who's connecting. And especially with how the trends with wireless technology is, as more and more devices are becoming integrated with wireless light bulbs, fridges, cars, TVs, more and more devices are connecting and broadcasting. So what do we look for? What we do when we're doing wireless pen testing typically is that we want to fingerprint the access points as well as the client devices. This allows us to identify any malicious or rogue access points in a client or environment. Once we've done that, we can also analyze the traffic between the legitimate access points and the clients. With this information, we can then begin to build comprehensive attacks based on this information. We gather this information by either passively or actively. And actively, we send packets. We create wireless packets, and we send them to the clients and the access points, seeing how they respond, what they send back to us. Or we passively listen, as a lot of this wireless traffic is unencrypted. When I say unencrypted, I'm talking about the management packets, including beacon frames. So this is one of the 4 packets that we often look for when trying to understand and get a lay of the land. So beacon frames, their purpose is to announce the presence of themselves in an area. They typically broadcast their physical address, the MAC address, as well as the SSID, which is the network name, the wireless network to dissociate themselves from other ones in the area. They also contain information about the encryption, the channel that they sit on, as well as other authentication information. This information is sent out unencrypted, allowing other clients to see, and if they need to, they can connect. They know that this is the network in this area that they want to connect to. This information is very good for us when we're fingerprinting, trying to understand what type of attacks we want to proceed with. So the next set of attacks frames are probes. There are 2 types of probes we often look for. First one is requests. Probe requests are sent by clients to look for any SSID in range that they've previously connected to. They send out these packets, hey, is X in vicinity? My address is Y. They send out this information, their own MAC address, as well as what they're looking for. If they don't get a response, they move to the next channel and repeat the process until they receive a connection. This connection only occurs when an access point sends a probe response, which is a response to that request packet, which basically says, I'm part of that network you're looking for. Here is the information that you need to be compatible with in order for you to successfully connect to me. And that is the data rate, the type of encryption, and the authentication schemas and ciphers have to be compatible. If they're not, there's a rejection and the connection is broken. Once this is all done, the next set, authentication, EAP packets occur, which is an extensible authentication protocol. Like I said, it handles authentication. There are many different types of authentications that it supports, ranging from credentials to tokens to TLS certificates. Most of these methods require a radius server, which handles the authentication for the access point. This makes the access point, in turn, act as an authenticator, which basically, like a man-in-the-middle device, when a client sends a request, it takes that authentication information, those EAP packets, and sends them to the radius server. The radius server then processes the request, and if the credentials are valid and the requirements are met, we'll send a success. And that authenticator will then allow that device access. If there isn't, we'll send a deny, and the authenticator will end and terminate the communication. So with all that type of stuff, here's an example of the typical tool that you would see out when you're fingerprinting and trying to gather a lot of this information. These tools have a plethora of information, but they can be a little convoluted and complex and hard to really get an understanding of what you're looking at. As you can see, the information is set up in such a way that it's two bars, one that grows on top of each other. Sorry, can you guys hear me now? Yeah, this lost. Test. Okay, so as you can see, the MAC address of the access point, the power. When you hear about power when it comes to wireless, it's denoted as how close you are. It's done in a negative range, and what it discerns is the smaller the value, the closer you are. So obviously you want to look for the ones that are close by and not worry about the ones that are in the 80s, 100 range, as that's when communications can start to become limited and delays can happen. You can also see the channel that they sit on, as well as the type of encryption, cipher, and authentication they use. If you look here at the bottom, you can see at number 8, probe. What this denotes is that these are the clients looking for a network. So these are what they're probing for. And you can see the client's MAC address at station and whether or not they actually connected. So this is a lot of great information, but it's sometimes hard to read, especially if it's coming in real time, as it can sometimes overwrite, pushing that bottom bar all the way off the screen, making it hard for you to understand what you see. Another thing that a lot of tools do is that when looking for or detecting hidden access points, ones that do not broadcast their name, if they detect a sequence of packets, a probe request sent by a client looking for a certain access point, and if that hidden access point responds to that SSID, it will mark it down that this is the name of it, which is fine, but it doesn't actually tell you this, which sometimes makes it harder when you're trying to identify hidden SSIDs in your environment. There's no way to detect it. I'll talk more about that in a little bit. So, the attacks. These are the common ones that we see a lot and we have the most success with. These are not all of them. More and more are coming out. Every time, depending on the environment, there's always a different way of doing it. I like to tell people that wireless is less of a science, it's more of an art. When we get down to it, these are the type of common network setups. Like I said, it's more of an art. These are not an inclusive list. These are just the most common ones that we see enterprises using. And they can be using a combination of them where they have one network meant for their company or corporate devices, a second one meant for guests or BYOD devices. And that typically is either like a captive portal where there's no encryption at all, but you are presented with a web application login field. And it could be a set of credentials, valid domain credentials, or maybe a common phrase that's shared between teams or floors or just one for the whole company. Another one is WPA2 pre-shared keys. This is a passphrase that is used. It's a single passphrase, and multiple devices can authenticate using the same passphrase. What we see more and more is enterprise-level authentication schemas as well as ciphers. And those are EAP-FAST, which Cisco has recently adopted into what they call EAP chaining, where you chain a series of authentications together. So that would be passing a set of credentials. Maybe it's a laptop's long cert name with a pre-shared key, and then their own software like Cisco AnyConnect, Cisco mobile clients, VPN, and that kind of chains a series of authentication. And if each one of them is met, that device is then allowed access to the network. The next one is PEEP, which is referred to as protected EAP, in which credentials are sent down an encrypted tunnel. Because of how old this protocol is, there's a systemic flaw with it that a lot of people often don't realize is that, yes, this tunnel is encrypted and credentials are sent down, but not all of it is encrypted. Usernames are sent in clear text, and once that is received, then the tunnel is created, sending the encrypted password. So if you were to look at it like this, you have your whole company, they have a BlackBerry, iPhone, laptop, they're all sending out their usernames out into the air for anyone to collect before they enter in their password. And that's a lot of stuff you can do with that for attack vectors. The next one you typically see, this one's a little bit more difficult to implement, is EAP TLS, in which each device is given their own TLS cert. This is the issue with this, from an attacker's point of view, is that it comes down to cracking the encryption, and TLS, to my knowledge, as at this point, hasn't been broken, like the current TLS 1.2. What I was saying before about difficult is that it's hard to manage each cert. You have to manage it for laptops, the employees' devices. Do they have a secondary device, or sorry, a tertiary device? And if your company has over 200 or 400 people, that can be a lot of things to manage. The next one is EAP TTLS, which is a combination of PEEP and EAP TLS, in which first an EAP TLS session is created, at which point a PEEP tunnel is created through that TLS tunnel, sending those credentials down. So, what is SniffAir? So SniffAir is an open source wireless framework. Its primary purpose is to provide a way to collect, manage, and analyze large amounts of traffic from pcaps or live capture. When we typically get on sites, we are not just asked, okay, walk around or try to hack. It's, here is our building of 40 floors. We want you to walk each single one of them looking for malicious traffic. So 40 floors, that's a lot of traffic. Hard to manage it, hard to figure out when you go back and review. Where did this access point match up? Which floor, where is it when you go back? So we developed this as a way to help alleviate that stress and manage it. So that way you can focus more on the analysis and the attacks. So it takes offline data, or you can feed it using a wireless interface, live captured data. What it does is we developed a comprehensive fingerprinting engine using Python and Scapy. And what it does is it breaks down each packet and groups it into one of 4 categories. Is it an access point? Is it a probe request? Is it a probe response? Or is it an enterprise authentication-based packet? Once that's done, it then parses each of those packets, looking for the important information that we just discussed, and then storing it into a string into a database. Once that's done, it compresses it, making sure that there's only unique values. So as we know that access points, clients, they are constantly probing out, looking for the same information. So you could have 100 or 200 of the same packet information in your database. So what we've done is we've stripped all that out so you only look at the unique ones. You can focus and drill down more into the information you want to see, not duplicates. So I've talked enough about it, so let me show you it. Everyone can see this okay? Just shout out if you have trouble seeing it. So, like I said, you can feed in live capture data or offline stuff. You can also store them in what we call workspaces. So I've done that already, so that way we can kind of show you how you can use this tool. So I'm going to load up this workspace. And each time you load it up, or if after you feed in information, you get a little dashboard. And you can see right now the top ESSIDs in this workspace. Now, we also provide you a feature called InScope, which I'll talk a bit more about. That allows you to just focus in on the ones you care about. Say maybe you're tasked to find out anything that's happening on a certain access point, a certain network. So you could focus in by using the in-scope command to separate everything related to that network into separate tables. And it will create a separate dashboard for you of information. So let me show you the first table. So first thing I just want to say is this database has over 275 rows just in this table. So this is in demo mode. The one on that we are using that's out there right now is not, so you see the full table. I just wanted to give you a good example of how a table could look. So you can see right now, all that information I was talking about previously is here for you. With regards to the power level, SniffAir only records the closest, the lowest value, because that's the closest you were to that access point. So the next table is the probe request table. So these would be the client devices looking for certain ones. And you can see the vendor of that device who manufactured it. The next one is the probe response. So in this table, we see the access point that responded, what name, wireless name did they respond with, who manufactured it, what channel they sit on, what are the requirements of encryption and authentication that they need, as well as which client did they respond to. The last table I'll show you right now, it's the enterprise table. So as you can see, I was talking about that before. There's an issue with HEAP, the protocol, where usernames are sent out in clear text. So what we've done is we pulled out the information so you can find out the MAC address of the device, the username, and which access point they sent it to. Now, this information is great because some clients may set up rules that say only Alice can log in from this specific MAC address. So with that information here, you can spoof the MAC address. You have the username. All you have to do is get the password somehow. There's other ways to get that. Now, it's not just limited just to those tables. You can perform other requests. So if you wanted to see all of a certain value across all the tables, you can just use the show command. So you can do show channels, show encryption, or let me just show you SSID. So this will show you every single SSID across all the tables recorded in your current workspace. So some of these might be devices that, client devices that have connected elsewhere, like maybe random hotspots, home networks. They're probing, which we could use to create evil twins to get them to connect to us. I also mentioned a little bit ago about the in-scope table. So I'm going to show you kind of what you can do with that and why we really feel like this is a very important part of SniffAir. So what we're going to do is we'll put two SSIDs in the in-scope. So one. So what it's done is it's gone through each of those four tables looking for information related to those networks and created separate tables loading them into it. So now you can do queries, maybe look at a dashboard, get just a sense of what you're looking at. We've created a module called SSID info. And I'll have to scroll up. But what you can see here is you get a brief dashboard of all the access points broadcasting that SSID, the vendor who manufactured it, all the channels that they're sitting on, and all the encryption that they use. So you can see right here that ha is an unencrypted network that sits on 11, 6, 1, 48, 40, 44, and 2. You can also see that Star Labs sits on 11, 48, 6, and 48. However, there's two types of encryption. So that's kind of weird. Why would there be two significantly different sets of encryption? I'll talk more about that in a little bit. But we saw before a lot of hidden SSIDs. So I mentioned that briefly talking about other tools, how they just change the value for you. So we have a module that passively probes all these tables, looking for all the hidden SSIDs, looks to see if a client requested a certain name, and if one of those hidden responded to it. You can do that by using the hidden SSID. And what that will do is it will parse through and update for you in the access point table all of these, as well create its own table for you to see in query. So now you know these are all the ones you discovered that were previously hidden. Now, say for instance, you wanted to look at something specific. We provide you the option to do your own custom queries using the query option. So I'll show you an example of that. But it uses just SQL syntax. And you can see that we've updated in the access point table that this is no longer a hidden SSID. We now see it as the name that it's actually. So going back, I mentioned that was kind of odd about why an access point, why a network has two different types of encryption. So we have a couple of modules that allow you to kind of get a better sense of those in-scope networks. It's called suspicious AP. So what this does is it goes through and says, okay, let's look at every other access point in the environment that you've collected. And let's look and see if there's any discrepancies. So the first one we look at is, hey, the channel. You can see right here. So you can see right here that 3 access points are sitting on different channels than the rest of the environment. Maybe that's a misconfiguration that you can let the client know. Maybe that is something malicious that you need to investigate further, but let's keep looking. The next one is vendor. So we discovered that an access point is using a completely different vendor than any of the other ones in the environment. Maybe that's a test. Maybe that's something that, hey, you know what, we should go and talk to the client about and see if they're aware about. Or maybe this is actually an access point stood up somewhere and someone is maliciously trying to attack the network. The final one is encryption. So this one is that big one because we went from a client, the Star Labs running as a management enterprise using strong encryption to one that's using no encryption. So this right here is something to be alarmed about. So this allows you to give you a quick sense of what's going on based on all the information you captured. Another module that we have is called the AP Hunter. So this module allows you, based on the information you have collected, find out what is in the area. You've walked the floors, you've walked the complex. So let's take a look and start making some queries based on the encryption and the range, based on the power. See what we can see. Maybe there's something that shouldn't be there. Maybe there's some access points that need to be decommissioned. So let's change the power to -60. Okay, so right now we see that there are a bunch of them within that range, but we don't see anything below that. Okay, but we know that ha is one of the in-scope ones, but we see 2 here. Follow the, and a hidden one. Maybe the client shares the floor with another vendor or a company, so maybe one of these is benign. Maybe this is somewhere that, like, I've seen it before, where the help desk has set up their own access point, plugged it into the network, so that way they can torrent and stream without them thinking the company can see them. So this gives you that sense of what's going on and how to help close those gaps in your network. So I have a couple of videos. Of some of the attacks you can do. So this first one is what we call auto EAP. And that is automated EAP brute forcing attacks. So we discussed a lot about how the EAT protocol sends out those usernames in an unencrypted manner. Brute forcing is a common attack vector that we use in web apps, networks, perimeters. Why can't we apply that same thing here? This tool addresses that. And as you can see that this highlighted SSID, BSSID, is one of the ones that are in our access point table. And we have all these usernames now. So what we can do is, using this module, create the handshake using a specified password and see if we can get any successful authentication. So load up the module. We have variables to set. We need to set up the interface that we're going to use. That's usually a wireless interface. The name of the network. In this case, it's honeypot. Then the type of encryption, as well as the password that we're going to try to use. So here we're going to use a very secure password to see if anyone's vulnerable. I really hope no one has this. See, all the variables are now set, so we can then begin our attack. So on this side, you can see that this is an actual Radius server. This is the output of a running Radius server. So you can actually see the authentication requests come in. So it seems that Alice has a bad password. Hacker does not. Now, using these credentials, maybe, for instance, as I mentioned, EAT TLS or something like that, they might use that as well, or something like that. But now you have credentials. You can log into perimeter apps, Citrix, VPN, Outlook, and perform further analysis. You can also see that we store all the successful passwords in a loop table. So we have it for further things. Maybe you want to try PostX and connect to the network. So in keeping with that, we also have another module called AutoPSK. Same sort of concept, except we don't look at enterprise EAT packets. We're looking at more of those home pre-shared key networks where it's a passphrase used by everyone. So we see we have honeypot running again. And this time it's running as a pre-shared key network. We're going to load this up. Now with this module, you can feed it a word list like RockU. You tell it the interface and the network name, and it will start brute forcing those passwords for you. And once it finds a successful one, it will just stop. You have that, you can then log in. There we go. So you see the first password failed. Now it's going to try the next one, and then the next one until it hits a successful one. Like I said, this is literally from the RockU word list. So some of those at the first are pretty obvious. So this network was, once again, using another great password. So This attack is actually a series of attacks that we use a lot against clients. It's called Evil Twin, in which case where you set up a malicious or masquerading access point to be able to pretend to be a legitimate one in range, and you try to get clients by passively or actively connect to you. Microsoft, Android, iOS have taken certain steps. Some have been more successful than others. So in this one, you can see we're setting up a certificate. So you can generate your own certs based on the information you have gathered. And with this certificate, you can then embed it into your Evil Twin, so that way, when a user gets prompted saying, hey, you just connected to an unknown network or something like that, they'll see a company's certificate. They'll see the name of the company. It kind of looks like this is all right. This is legit. This is my company. Accept. And in some cases, actually, this isn't one of the few cases, but I'll talk about that in a little bit. But there are some misconfigurations that iOS has, in which that if you view the certificate, even if you decline it, in some cases it will still send the credentials, even if you haven't accepted. It's a flaw with the handshake. So you can see here we've set up all these variables, one more variable away. So we're now going to generate the cert. Once we have this generated cert, we can then start using it. And there are two forms of Evil Twin attacks. The first one is just trying to capture the MS-CHAP v2 hash. So what that entails is that a machine has connected to you, and they've disclosed this hash. Now you can take that hash and load it up into John the Ripper, Hashcat, and then perform offline password cracking. The other one is what we call the GTC downgrade, in which you force the client to downgrade the communication to GTC, where the issue with that, and it's no longer used, but it's still available as an option, is that the credentials, both username and password, are both sent in the tunnel unencrypted. GTC downgrade only works on iOS, OS X, and Android. Microsoft Windows is not vulnerable to it. So that's why we've included this MS-CHAP attack as well, so that way you can still be able to attack Windows machines. So once we've set those variables, we're going to run the module. So it's spun up a legitimate access point. And what we'll see is as users start probing, they'll connect. We can see that Alice and Bob have both disclosed their corporate credentials. So now I'm going to show you the GTC, where we can get clear text passwords. These type of vulnerabilities are typically caused by misconfigurations with the clients, where they do not validate or even look at the certs. In fact, in Android, you can spin it up and they'll never see the cert. And everywhere else, you'll see a cert. Maybe even if you hit decline, you'll still send the credentials. If you have it set up properly, it will only allow for certain ones. So being able to have this ability of having both these attacks at your hands will allow you to have a much higher success rate. So with this case, we're still spinning up an Evil Twin access point, but we're now connecting a radius server. You can see that with this Android on the side, you haven't seen a cert yet. Just click connect. And now the second one, unfortunately, Apple does not have an ability to let you screen record for privacy and other apps, but you can see that there was a second handshake. I'm going to show you what that looks like. But you can see the credentials from both those attacks. So here's what that certificate looks like. And if you decline it, you still disclose the credentials. It's one of those flaws. The final attack that we've included in this framework as of right now is what we call the captive portal. In essence, what it is being able to spin up an open network with a convincing web application. Currently, we only have one template, which is a Cisco authentication login portal. So it just looks like normal Cisco username and password fields. But what's interesting is that devices, if they are probing, if they've previously connected to this before, and you're in the area and they connect to you, they'll instantly load the application. You won't be asked to say, hey, go to this IP address or do anything like that. They'll just bring it up and say, hey, you got to give me your credentials. Which, as a user, you're just going to think, okay, my session has expired. Re-enter my credentials. And what happens with this module is it takes them, shows you a success message, then kicks you off the network. You can see that right here once we finish up setting up the variables. So we're going to spin up an access point. We're going to spin up a web server, as well as we're going to configure the DNS so that way we can filter and block using IP tables. So once it's launched, we'll then show you an example of what it would look like from a user's perspective. So here's an Android. This affects every single one, Windows or anything like that. They see the network. They've connected now. We haven't previously connected, but it instantly loads a Cisco page. Type in your credentials. And once you hit submit, you can see them on one side, and boom, kicks you out. And of course, all these credentials are collected and stored in our loot table for you to view when you need to. Show you, okay. So, to recap, SniffAir is an open source wireless security framework that allows you to parse and pull out information that you need to help you understand the environment, to allow you to perform queries, and then to perform attacks against clients and access points in a network. We're constantly building this. Actually, today marks the release of version 2 with all these new attacks in there. We are continuously building. We're always looking for community ideas. We've had great feedback. If you feel free to ever send us a message about some ideas, maybe there's a bug or anything like that, or if you just like the tool or want to talk about it. You can reach us at these Twitter handles, as well as here's a link to the GitHub. Everything is up and active, and you guys can start playing around with it. Just remember, use this wisely and ethically. That's it. Any questions? So we started building that. Unfortunately, we don't know if we're going to get to it, have it ready for people to use on the public GitHub this year. But by January, you'll be able to either clone a site and then import it into the templates, or have the ability to have a structure where you can actually fill in or take your own and make your own. You can. In that demo, it wasn't just because the complexity of just doing the video, but you have the ability to do that. We also are we just recently are going to be implementing in the ability to feed it in multiple passwords. So you don't have to do it one at a time. You could be Alice, this password, Bob, and then it will repeat the list continuously. We are messing around with controls around that for delays, so that way you don't cause lockouts or anything like that. And that's where the holdup has been, because it's kind of hard to sometimes stop partway through wireless traffic. Yeah. You can set it to do that, or you can just use it off like that. A lot of times, because of how AutoEap works, is that you're integrating with the WPA supplicant and that. So you might get a success, but it may not allow you access. So what this is done is, hey, this is valid, but you can't log in. So that's when you can then do MAC changer and then spoof the MAC address. Any other questions? Okay, thank you guys.